Welcome back, friends. Welcome back to another new problem solving video. This is Ritavan, and today our topic of discussion is hydrostatics. Today we are dealing with a question which states something like this: a hollow cone whose weight is half of the water it can contain floats in water in stable equilibrium, where the cone's axis is vertical and its vertex is downwards. Prove that if alpha is the semi-vertical angle of the cone, then we will have an expression cos to the power 6 alpha is less than 729 by 1024. Okay, so at first let us perform the first things first. It is said that the hollow cone has its axis vertical and vertex downward. So at first let us draw the cone. Suppose say this is our cone. Fine. Now this is the base. Let us name it as O. This will be the radius. Say name it as AB, and this is the height of the cone, such that let us say the height of the cone as H. Fine. Now the next part. It is given that this cone floats in water in stable equilibrium. Say some part of the cone floats in water. Say this much. This is the amount which floats in water. So we are having here another mini cone which is not hollow but solid in structure, right? So let us name this radius as CD, and let's consider this height to be Y. Now what does the question says? And the word is downwards. Prove that if alpha is the semi-vertical angle of the cone, alpha is a semi-vertical angle, means this part is alpha. Okay, so by trigonometry, this is the height H, this is angle alpha, then we will have the radius of the big cone or the hollow cone as H tan alpha. This is by plane trigonometry. Next thing, in case of the smaller cone, which is not hollow but solid, this one's radius will be Y tan alpha, since the height is Y. Fine. Now let us consider, let rho be the density of the hollow cone, the density of the complete cone. It is given by rho. Now what will be the weight of the total cone? Weight of the cone, the complete cone, equals mg, which is given by volume into density into g. Volume of the cone will be 1 by 3 pi r square. R here is h tan alpha, hence we have h tan alpha square. Pi r square h means again h, and we have rho and g as it is. So we are having it as 1 by 3 pi h cube tan square alpha into rho into g. Now we will have what will be the weight of the water? Since the cone carries water, so we have to also find the weight of the water. Weight of the water will be given by same mg, which equals to v volume into density into g. Density in case of water we know as 1 gram per centimeter cube, so put in here 1 into g. So we are having v into g, which will be 1 by 3 pi same h tan alpha square by r square h into g. So this is our volume of water. Now the question says that the hollow cone whose weight is half of the water it can contain. So if this is the weight of the cone, it contains half the weight of water. So according to the problem, or say weight of the cone equals half the weight of water. So if we equate these two, I am taking this part, it will be easier for calculation. 1 by 3 pi h tan alpha square into h into rho into g, which equals 1 by 3 half into 1 by 3 of this part, h tan alpha square into h into g. So 1 by 3 pi gets cancelled, h tan alpha square gets cancelled, h and h gets cancelled, g and g gets cancelled. What we are left with? Half. So we have here as half. Say this is our equation 1. Let's name this equation 2. This is equation 3. So we have got that the volume, the density of the hollow cone, of the total cone, as here half. Now the question says that it contains the cone floats in water in stable equilibrium. We have considered that this amount or this part of the cone floats in water. Okay, so from this we need to find the weight of the water. Weight of the water means in this part. So we can appropriately write it as weight of the displaced water. So we will have the weight of displaced water, which will obviously be equal to the part of the cone which has immersed in the water, isn't it? Which is given by similarly mg, which means v into rho into g. In case of water we know rho as 1. So v we have as 1 by 3 pi r square, which means y tan alpha square into y into g. Noting here why we are taking here y tan alpha, since if you look at the diagram, this is the amount of area, or rather say this is the weight of water which has been displaced by this part of the cone. So this part of the cone we have here the radius as y tan alpha. So that's why we are taking here the weight of the displaced water as y tan alpha. Fine with it. Now the body, say let us name this equation as 4. The question says that the body floats, which means what? That the body is stable. This implies the body is stable. Therefore by Archimedean property we have weight of total cone, which means the complete hollow cone is equal to the weight of displaced water. Since the body is floating, it is of course stable, and since it is stable we can say these two weights are equal. So what we had, the weight of the total cone, we put in here this expression, okay, then one expression. So how it will look like? 1 by 3 pi, 1 by 3 pi gets cancelled, tan square alpha, and here you also have a tan square alpha which gets cancelled, g and g obviously gets cancelled. What we are left with is h cube, and these two multiplied give us y cube, so we put here y cube down here equals to 1 by rho. And here we already got last expression from 3, that rho equals to half. So this becomes rho, put here half, then it will be 2. This we have got from equation 3. Hence we have a relation that h cube by y cube equals 2. Let us name this as relation number 5. Now in order to be for stable equilibrium, this is the principle for stable equilibrium, hm should be greater than hg, where h represents the center of buoyancy, b represents metacenter, and g is the center of gravity of the whole system. So h would be somewhere in here, right, since it is the center of buoyancy. Say let us consider g to be somewhere here, the center of gravity of the whole system. Now hm is greater than hg. We have the formula for hm we have as ak square by v, where a represents the area of the immersed part of the body, v represents the volume, and k is the radius of gyration. So a we have as pi r square. Area is actually, if you look at the compare the diagram, this part, this is the area, and what this represents, this obviously represents a circle. So we have the area as pi r square, or in this case pi into y tan alpha square. So we have here pi into y tan alpha square. Radius of gyration in case of a cone, this we have to remember as half y tan alpha whole square, and volume is given as 1 by 3 pi r square h. Now if we cancel this out, we will get pi gets cancelled, y tan alpha square gets cancelled. We are left with 3, this becomes 4, y gets cancelled, we are left with 1y tan square alpha. So this is our hm, so we have got it. Now we need to find hg. hg, as per diagram, if you see, what will be the hg? This is h, this is g, so this distance we need to find. This will obviously be og minus oh. Therefore hg equals to og minus oh. Have og equals to, since this is of the hollow cone, 2 by 3h, and oh, since this is a part of the solid cone, we have here 3 by 4h, or sorry, 3 by 4y, because the height was y in case of the solid cone. So we have got hg. Now we will equate these two, that this part is greater than this part. Therefore 3 by 4 y tan square alpha is greater than 2 by 3h, that's 3 by 4 y. 4y tan square alpha 12, this is 8h minus 9y. Now this is normal calculation. These are 12, we will have y tan square alpha is greater than 8h minus 9y divided by 9y. So this part will become 8 by 9 h by y minus 1. Sorry, here will be no y because we have shifted y to the denominator. Here we have 1 plus tan square alpha is greater than 8 by 9 h by y. 1 plus tan square alpha means x square alpha greater than 8 by 9 into h by y. Now if we reciprocate this, this gives us cos square alpha, this will be less than 9 by 8 y by h. Now if you look at our proof, this required cos to the power 6 alpha, so we cube both sides. Cos to the power 6 alpha is less than 9 cube means gives us 729, and 8 cubes, which is 64, 512 y by h whole cube. So we will have cos to the 6 alpha is less than. Now look at in here, we had h cube by y cube relation equals to 2. So here we have y cube by h cube. We will just reciprocate this, 729 by 512. This will be 1 by 2. So we have cos to the 6 alpha is less than 729, 1024. This is our proof. Done and dusted.